Oh, right. Good life choices. I'm so okay. For those of you guys just joining us, we are starting notes on chapter 5. I did not get your homework spirals. Oh yeah, we have like 12 pieces. I did not get your homework spirals graded. Dean, Gavin, Patricia, and Mike. Got it. So I'm going to do a 4-minute check where I take a peek at 2 different random assignments and walk around. And as I do that, you guys are taking notes on chapter 5. For anybody who forgot to turn in corrections on Friday because I wasn't here, I was observing Mr. Grapp teach. You can still turn in corrections by the end of the day, giving a little bit of grace because I did not mean for it to be as confusing as it was. As far as, I don't think I reminded you at all on Friday about corrections. So chapter 3 corrections, get them in. But as people are taking notes, I was telling them to get a quick sketch of these relative extreme value theorem. We were just starting to talk about what additional fact on the EBT card, on the extreme value card, did I add in last year? Who remembers? That is continuous on a closed interval A to B, then F has both a max and a min. What did I add in to help you actually find that max and min? That's for relative extrema. This says a max and min. Doesn't say a relative. Doesn't have to be at critical numbers. Did I not put that EBT? Maybe I didn't. I thought I did. Has a max and a min, and they will occur at either. Is it occurring at 2 up? I think just one, right? I don't know why it was written in my head. Occurring at either. Crits, I agree. Or endpoints. And that's the whole dilemma if the interval becomes half open or totally open, because then I don't have endpoints. So there could be holes at endpoints that are higher or are lower than the critical numbers. But if I have endpoints and if I have a continuous function, then I can look at my crits, I can look at the, but don't I have to test in a function table? We also have absolute extrema. Testing for absolute extrema. So it might be that I have most of it there as far as we're testing at critical numbers or endpoints by plugging into the original function. But EBT, F has to have both a max and a min because of those endpoints. That's the key, because of the endpoints. The continuous function with endpoints, or with or on a closed interval. Anyway, you have quick sketches of all of that. That's all well and good. We'll come back to some of this, but what I want you guys to do as I come grade your homework is review everything relative extrema-ish. Review everything having to do with finding relative extrema. Do you guys have sketches at least for these local dudes that we're going to talk about? Okay, then let me zoom in on the top of this and then I can just scroll down when we have it. Alright, so your table of contents are open in your homework packet or homework spreadsheet. I'm going to come and ask you to turn to 2 random pages in that table of contents. If you got them, we're good. It's a check and we're moving on. If you don't, I'll tell you what's wrong and give you an adjusted score. You guys see our pitchfork? Remember, not just critical numbers, but before that we have to think domain. Okay. Okay, let me scroll down. This is where it gets to be fun. The difference between a first derivative sign chart and a second derivative sign chart. A first derivative test for relative extrema and a second derivative test for relative extrema. And for those of you guys that are just chilling, your homework is on Google Classroom if you want to go find it. Maybe not the pages, but the homework problem numbers. Alright, let me scroll down all the way, because I don't think we got the entire second derivative test up there, right? However, what's in common, even though there's a lot different, he has a sign chart, he's plugging in, he's looking at increasing, decreasing, he's looking at concavity. What's the same with 3 or 4? This is a big or. We don't have to do both tests for relative extrema. Both of them can show me relative extrema as long as it's a smooth turn. But what's the same? Not the characteristic, not the way we do it. But what's the same? Who we're using. Right? Don't they both use crits? Both tests, whether you're looking at an increasing, decreasing sign chart, or whether you're plugging in and checking concavity. Remember, second derivative test only works with smooth turns. continuous absolute time exists and is non-zero. If it's zero, well, we can't really tell anything because it's not going to be a positive or a negative. First derivative test, relative extrema are found by changes from increasing to decreasing. Second derivative, what's the concavity, or is there any? Alright guys, if I said good, you can give yourself a 15 out of 15, and if you got anything else, I should have written it down for you. All you do is forget those. Thank you so much for doing 4-man. Four-man's homework check, I appreciate it. Not 4-man's stuff. Alright, did we review the relative extrema page? Woo! Why am I making a note of that? Local extrema? What other kind of extrema is there? So we have relative, we have local, we have EVT that says if I have a continuous function on a closed interval, there will be and I tended to allude to, hey, not just critical numbers, but endpoints are important for EVT. But we didn't specifically say, okay, what about absolute? Ooh, it gets exciting after that. So hold on, let's get back to the beginning. All right. Absolute extrema, the highest, the lowest of a function or graph. Do you guys see that original? Can I make them bigger? I'm still getting used to these new buttons. Stink. There we go. What's weird about the example that I gave you? Why is it there? Because x squared plus 1 doesn't exist there? No, it exists there. But it's not a whole in context of the function. Isn't this guy's domain all real numbers? He's a polynomial. So why did they put the whole? No, derivative exists. Not vertical. Here, if you guys see it. They're saying just look at the open interval, and if you look at the open interval, we're not looking at the endpoints. So they're putting holes, not because the original function has holes, but because the open interval said think of them as holes. And what's the problem with holes? Why not just go right before 2? What is right before 2? But I can get closer than 1.9, can't I? I can get closer than that too, yeah? So what's the struggle? There is no closest. There is no right before 2, right? Because there is no right before 2. It's 1.9. I don't have a highest. It's just getting closer and closer and closer to 5, but there is no actual max if I can't use 5. 5 is the limit, but if I can't use it because I can't use the endpoint, well then forget it. I don't have a max. But why was there still a min? So, do I need to still consider, even when thinking about absolute extrema, do I still need to consider critical numbers? Do I still need to think about relative extrema? Because could some be both local and absolute? The answer is definitively yes. Okay, so moving on down. Extreme value theorem. I already talked about him just a little bit. Yes, he's your forever card. The main factor that has to be there is continuous and closed for this to be guaranteed. Right? But if anything is different, if it's not continuous, or if anything is different, it's not closed, it's not guaranteed, but could it still be true? Yeah, sure, why not? We just have to test both critical numbers and endpoints. If you guys notice, if this is the absolute extrema page, do you see why I put critical numbers, endpoints? We have to test them in the table. Yes, it's EBT, but it's also how to find absolute extrema. We have to take those critical numbers, we have to take those endpoints, and we have to test. Now, here's the dilemma. What if they ask us to find absolute extrema? But it's like an open interval instead. What if they ask us about absolute extrema, but it's an open interval instead? You can't? True, but if it's an open interval, shouldn't we still think about where it would be? So just because it's an open interval doesn't mean that I stop looking, doesn't mean that I say there are none. It also doesn't mean that there are both. There could just be one or there could be none at all, no absolute min or max. Oh, no. But even if I have an open interval, I still have to think about it somehow. So my clues to you guys would be to still consider the illegal absolute extrema. Because if it's an open interval or partially open, still consider the illegal ones. The illegal ones are going to be the endpoints for analysis. Now maybe it is a vertical asymptote, or maybe it is a hole, or maybe it's something where you do have to think about the limit and it's not enough just to plug in. But consider the illegal endpoints, whatever is not included in the interval. Still, figure it out so you can compare to what else you have. But then also think about the function behavior. What do I mean by function behavior, guys? How do functions behave? How do they change? How do they move? What do functions do? Yeah, increasing, decreasing, or constant, right? Remember, functions, aren't they just y values or aren't they just heights? So the function behavior is the same thing as the y value behavior, is the same thing as the height behavior, is the same thing as increasing, decreasing, and how it's increasing, how it's decreasing. But specifically, I was thinking increasing, decreasing. So still think of your sign chart. Still think about your endpoints, but just know that they're illegal if they're not included. Does that kind of make sense? I've seen the AP guides more and more ask for absolute extrema with open intervals because they're trying to see if you know the concept and not just the, all right, test the critical numbers and endpoints and you're done. Then we got interrelative. Let's zoom in on these graphs that you guys could probably barely see before. How would you have found the relative mass of the one on the far left? Tell me about it. What's going on at this point? Huh? Critical point, yeah. So it would be a horizontal tangent line, right? And it would be when the derivative is equal to 0. I have a horizontal tangent line. Question: would my first derivative test have worked? Is there a change from increasing to decreasing at that point? Would my second derivative test have worked? Why? What kind of concavity is at that point? Concave down. So whether I did increasing or decreasing, or whether I tried concavity, either one, it's at a critical number, it's at a horizontal tangent, and yeah, there is a change in increasing or decreasing, there is a concave down nature. How about letter B? Sharp point. Sharp point, what's going to happen when I try to take my derivative and find that, oh, it's going to DME instead? Remember, relative extrema can be at, and so can absolute, at zeros or at DMEs. Hence the pitchfork, right? So I have a sharp point. Would my first derivative test have worked? Is there a change in sign of the slopes before and after? Is my function decreasing and then increasing? That's totally fine. How about my second derivative test? Would that have worked? No. Because if I plugged in, guess what? My f double prime would not have existed because is there concavity? So that's a no. Look at this guy. What's going on? HTLs again, right? Horizontal tangent lines, set the derivative equal to 0. Uh-oh, but what's the struggle when I set something like this equal to 0? How many zeros is it going to have? Infinitely many, true. So we have to be careful of whatever interval they give us and find all the possible ones in between. So it's going to be multiple and actually infinite, and we just have to narrow down based on whatever interval they give us, yeah? Would the first derivative test have worked? Yep. Would the second derivative test have worked? Yep, because we have that concavity, right? Which of these are absolute extrema? If we were to assume that these keep going. Second? Yeah, that's an absolute win, right? How about this one? Yeah, it's probably going to level out like the horizontal axis or something like that. Or maybe just keep on decreasing, but either way, from what we can tell, it's an absolute, right? But no minimum here, no maximum there, true? What this do? Huh. It's not at one place, but is there an absolute highest and lowest? So even though the whens are going to be weird, I still have a highest and lowest, right guys? And with that, can we review? Whenever we're talking about extrema, maximum, minimums, etc. What goes in what blank? We're asking for the let me say extreme value. Is that okay? Let's get that word value in there. They usually use that. Who's who? At least most of you made a mistake at some point last year in the question. Value of. What are they asking? Yeah, that's the y value, aka the function value, right? The f of x value, or the velocity value, or the acceleration value, or whatever it is they want the max of. The growth rate, which would be the derivative value. The value of, that's the y dude, right? But the at, or the when, or the for what value of the x, that's what goes there. True? So make a note of that. This is where they love to get you tricked. You're looking for the y, not the x. But will the x be an absolute? Sorry, not absolute. Will the x be a multiple choice answer? Oh yeah, well you know them. You know them. Come on. Okay, so all this led us up to the next page, true? And the next page was a grand old finale of everything to do with relative extrema and how to think about it. Now guys, we did already think about the first derivative test and second derivative test, and we already reviewed it. But can we please go back to something so basic in Algebra 1 today? Oh, it was so rough. I have a test coming on Wednesday. They have to solve exponential equations by making the bases match and then just set the exponents equal to. They have to do things with geometric and arithmetic sequences, just basic and yet kind of tricky. But I had their opener today be back to the basics. Because I needed to remember how to break down something like 625 and figure out that it was 5 to the 4th. Or they had to do something as basic as x minus 3 equals negative 2. Yeah, believe me, they needed to review that. Because if you can't do the basics, you're going to mess up every single more complicated question that needs the basics. So you guys, what are the basics of extrema? Where they might try to trick you? Domain. So be careful of domain. can there be a relative max or min at a non-existent original value? No, there is no max or min if it doesn't even exist. So there won't be a max or min at a hole. There won't be a max or min at a vertical asymptote. You can automatically, yes, still think about them in sign charts, etc. They're important because they break up the graph, but do not ever say he's a max or a min. Ugh, so easy to tell you and so hard to actually keep you from making a mistake on. So watch out for the holes in vertical asymptotes. Still put them in your sign charts, but know who they are. Know that they are domain problems of the original. Discontinuities cannot be extrema, but they're still important for analysis. All right, with that, yeah. Oh, back, yeah. N is even, sorry. For even, sorry, that was before the semicolon. I'm talking about nth roots when n's are even. If it's a cubed root, a fifth root, a seventh root, remember domain is all real numbers, who cares? But if it's a squared root, a fourth root, a sixth root, then I have to say that the argument u has to be greater than 0. So maybe it's not bad for us to write this down real quick. Remember, every even root argument has to be greater than or equal to 0. Every logarithm, because of that vertical asymptote, is greater than 0. And then you have stuff like trig. I just gave you one example where it's like, hey, he can't be the vertical asymptotes, right? I'm just going to put dot, 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 so we know that it continues forever and ever. Pi over 2 and 3 pi over 2 and 5 pi over 2 and 7 pi over 2 and all those guys. Okay. Let's see what you guys come up with. I want you to fill in as many of these as you can. Oops, it's kind of off the screen, sorry. This is a graph of f. This is a graph of f. Don't worry, the whole f, f prime, f comparing graphs and getting characteristics, that's coming in a couple sections. Right now, you have a graph of f. Tell me what you see. Tell me what you see. Take a second, sketch the graph.
There's some local maxes.
Local maxes and mins, that's good. Did you guys notice that Kevin was very particular about saying local? I think he sees a vertical asymptote that might screw everything up for absolute. I see smooth terms, don't you? See a discontinuity. I see a point of inflection. Whenever in math we're talking about describing and we're actually asking for when or where something is occurring, what kind of intervals are we using again? I guess I gave it away. I said intervals, but which variable, x or y? Always in terms of x. Always in terms of x. What do you guys think about domain? Are you there yet? No, a couple more seconds. We're still ready to go. Just think one characteristic, domain, and work your way all the way across. F's domain, F prime's domain, F double prime's domain. Maybe I should have given you a harder example. Do you guys want me to make it one step harder? No? No? I would put a sharp point. That would make things more fun. Or a vertical tangent line. Awesome. Okay, what's the domain of F? Do we have it? Let's just start with one, just one. What's the domain of F? Yeah, negative infinity to g and g to infinity, right? Or we could say x not equal to g. That's true. Will g be in my sign charts? Yes. Will he show up in my critical numbers? Yes. My pips? Probably. It's a denominator of 0, and those denominators of 0, they stick around for every single derivative, usually. He'll be there, but is he able to be anything helpful? Is he any relative extrema, any local extrema, any absolute extrema? Nope. He'll be there, but nope. That's a deal. A number over 0. So what's my domain of f prime? Where does the derivative exist? Y everywhere but g. Yeah, it's going to be the exact same as f. How come? When do derivatives not exist? At discontinuities, check, we got one. Anything else? When the limits don't agree, which is like a sharp point, from one side the slope is different than from the other side, with an abrupt change in between. Or when we have a vertical tangent line, because what's vertical slope? BNE, because it's infinite, right? It's infinite. So we don't have any vertical tangent lines, we don't have any sharp points. Okay, fine, it's the same everywhere but G. How about F double prime? Ooh, that's harder. Where does the function have concavity or lack thereof, like 0? Everywhere but G, right? Okay, well, we're fine. We're fine. We could try to get the graph of the first derivative and then try to think about the second derivative and see if there are any vertical tangent lines or sharp points on the first derivative graph. But that's okay. For right now, we'll just say zero. Okay, increasing. What is F increasing? E to G. You guys agree with Kevin? Are there 3 places? Why did we have to split up a G? Yeah, good. It's a discontinuity. I can't include G on an interval. If I did, I'm wrong or false. So from negative infinity to B, and then we have from E to G, and then we have from G to infinity. We cannot include G. If he was a point of inflection, we would, but not a vertical asymptote. He's not even a point. How about F prime? What are the slopes increasing? Not negative infinity, that'd be bad. Because those positives are going to 0. That's not going up. A to B, no, careful. Because the slopes, aren't they going from positive numbers to 0, which is actually decreasing? E to B to E, not B to E, because technically don't the slopes go from 0 to negative, which is still decreasing? C to E? Better. I'll start at C. I agree with that. C to what though? Why C to G? Whoa. Whoa. Oh wait. F prime is increasing when his derivative is positive. AKA when F is concave up. Isn't F concave up that exact same interval? Isn't concave up part of the definition that the slopes are increasing or the derivative is increasing or the derivative's derivative is positive, right? The derivative's derivative is positive. Oh, well, if the derivative's derivative is positive, then the derivative must be increasing. So is there anywhere else I have a concave up portion of my graph? No. Nope. Okay, well, check it. That's the only concave up. That's concave down and that's concave down. So what can we answer right away about where F prime is decreasing? How about everywhere else? So negative infinity to C and then G to infinity. Oh, we can also answer that with when F is concave down. Remember, concave down, yes, I know it's like a frowny face on the original graph, but isn't it also when F prime is decreasing? And concave up, yes, it's a happy face on the graph, but it's also when F prime is increasing. What am I missing? Oh, when's the original function decreasing? We have to finish that one. B to E, right? So do you guys see what separated the increasing, decreasing versus what separated the concavity? We're separating here at B's and E's and G's. So what was the separation for increasing, decreasing? Horizontal tangents and discontinuities, right? That was separating my increasing and my decreasing. But what was separating my concavity? Weren't those my points of inflection and my vertical asymptotes? Discontinuities can be separating all sorts of stuff, increasing, decreasing, or concave up, concave down. But otherwise, points of inflection separate increasing, decreasing also separates increasing, decreasing of the derivative. Now, we're purposely going to leave these ones blank anyway, so we're for it now. Alright, cool kids? Woo! We talked through a lot. Does that mean you're totally ready to do all of homework? Ah, maybe. But it's not due until Wednesday, so it's up to you. Because we have a few other things about increasing, decreasing, talking about content. Bye guys. Let me call the video.